Okay, so this lesson is to actually use the factoring we've been doing. So I've given you a function in standard form, and what I want you to do is graph it using the intercepts. But the only way to know the intercepts is for us to put it into factored form. So one quick thing about this graph, since it is a cubic that is negative, so it's odd and negative, we know that our end behavior will look something like this, right? Odd and negative with a cubic, two terms. Okay, but let's go ahead and put it into factored form and find the actual intercepts. So to find the x-intercepts, to find an x-intercept, you know that that's x comma 0. So y is 0, so I went ahead and put in 0 for y. And then we're going to go ahead and factor. Remember, the first step of factoring is always to take out our GCF. And I put a little negative in parentheses here because anytime that leading coefficient is negative, factoring is a pain in the butt unless you take that negative out. So for us, the thing that they have in common, their GCF is going to be, our GCF is going to be, we can take out negative, and we can take out, each of them shares an x. So we're going to take negative x out of everything. So I went ahead and took out negative x from everything. And if you wanted to double check to see if I did it correctly, you can always distribute this back in. And if you did, you'd be right back up where we started. So negative x times x squared, that's negative x to the third, so that looks good. Negative x times negative 2x, that's positive 2x squared, that looks good. And negative x times positive 1 is negative x. So I know that I've GCF'd correctly. Okay. Then what's left is a quadratic trinomial. That's our normal from last chapter. So we need to factor that with a table, right? So I've got a little table here where I went ahead and put in that we would be doing a sum table because the 1 is positive. Our only choices are x and 1 and 1. So I went ahead and those 1 and 1 do have a sum of 2, so that looks good. Went ahead and factored it. Both of the ones will have to be negative so that we get our negative 2 in the middle. And then the next step, it really helps us to rewrite any factors that we have in common. So x minus 1 and x minus 1, it's really more helpful to see that as x minus 1 squared, because then we know we're going to have a bounce there, right? Anytime we have a square, that's a bounce. Okay, and then the last step would be to find the actual x-intercepts. So find the solution. So we've got two factors. When is negative x equal to 0, and when is x minus 1 equal to 0? Those are our two factors. So this first guy is equal to 0 when x is 0. This guy is equal to 0 when x is 1. And that's what I've got here. So we know we have a solution at 0 and a solution at 1. We said the 1 was going to be a bounce. And the 0, since it's just x to the first, that will just cut straight through. So I'm going to go ahead on my graph and put a point at 0 and a point at 1. We know we're going to start high. If we look back at our original sketch, we're going to start high, end low. So I'm going to start high. I come down to 0. I cut through 0. Turn around. At 1, we said we're bouncing. So this guy looks something like that, right? So this is just the point of this lesson. Just take something, factor it, and then sketch. So I've got two more examples for you to watch if you'd like. All right, next example is a quadratic. First thing we should check for, or I'm sorry, it's not a quadratic, it's 4 terms. It's a cubic polynomial. Go ahead and plug in 0 for y so we can find our solutions. Definitely check for a GCF, but all 4 of these share nothing in common. So there is no GCF in this one. So we're going to go ahead and now group. Anytime you have 4 terms, we want to group. So we're going to group together these guys, the x to the third minus 5x squared, take out a GCF, and then separately the negative 4x and the positive 20. Okay, so out of the first group, our GCF is going to be, what do they have in common? X squared. So we're going to take an x squared out of that. The GCF of the second group, we can take a negative 4 out of both of those. So here's my work taking that out. You can see I took the x squared out of the first group, and what's left was x minus 5. I took a negative 4 out of the second group, and what's left is x minus 5. Remember, that's what we want. We want these guys to match. Then we know that we've grouped correctly. So since those match, what we did in class when we were working on factoring is we took those guys, they're our new GCF, took that common factor, x minus 5, and put it out to the front. And what was left, once you take out the x minus 5s as the GCF, what's left is x squared minus 4. Okay, that x squared minus 4 makes me a little worried. We need to check and see if we can go further, which we can, because it's the difference of squares. X squared is a perfect square, and so is 4. So we can take that further into x plus 2, x minus 2, and we still had our x minus 5 in the front. We don't have any common factors, so there's no way to rewrite. So we're ready for our solutions. Write the solution. So what makes the first factor equal to 0? That is 5, right? The second factor, what makes it equal to 0? That's negative 2. And the third factor is positive 2, right? So our solutions are 5, negative 2, and 2. And since none of those have an exponent on them, each of those will just cut straight across. Right, so at, let's see, at negative 2, at 2, and at 5, we'll be cutting across. I forgot to do my original sketch. Let's look back at the original problem. So the original problem has an odd exponent with a positive coefficient. So we will have something like this, right? Start low, end high, so that it's a positive in the front. Okay, so start low, end high, and each of our intercepts we're cutting straight across. So across, across, across. So something like this would be our graph. Okay, let's try another one. One more example. So again, I want you to graph this, but you have to find the solutions, find the x-intercepts. So first things first, plug in 0 for y so we can find our intercepts. Then GCF always, do we have something that comes out of everything? So 2 can be taken out of everything, but no x's. So let's just take the 2 out, double check that. Make sure if you distribute that, it ends up being the same thing as what it originally was. So 2x to the 4th, negative 20x squared, and positive 18. Yep, looks good. And then what's left is not a normal 3-term, but remember, as long as the exponents are double of each other, then we can treat it like a quadratic and do our table method. So I went ahead and made us a table. It's going to be a sum table. We've got x to the 4th and 9. Since 9 is positive, that's why it's a sum table. And then I wrote out our possibilities, except if you remember in class we said we would never do this possibility with x to the 3rd and x. We need it to be squared and squared so that we get the squared in the middle. Okay, we need a sum of 10, so we will be using 1 and 9. And if we want a sum of negative 10, they will both have to be negative. So that's what I did. X squared minus 1 and x squared minus 9. All right. This one, I rigged this problem so that this guy would be a difference of squares, and so would that guy. X squared is a perfect square, so is 1. X squared is a perfect square, so is 9. So these are both difference of squares. So the x squared minus 1 is going to become x plus 1, x minus 1. The x squared minus 9 will become x plus 3, x minus 3. So if you take a look at those, we have no repeated factors, so that's pretty much done. We just need to figure out what our solutions are. So what are x-intercepts? What makes that first parentheses equal to 0? That's a 1. What makes this one equal to 0? That's a negative 1. The third one, positive 3, and the fourth one, negative 3, makes it equal to 0. Since this 2 in the front doesn't have an x with it, it doesn't really affect things. Okay, so our solutions are 1, negative 1, 3, negative 3. So let's put those on our graph. 1, a negative 1, 3, a negative 3. And again, I forgot my sketch. Let's go back up and look. So our first term is a positive, even combination. Positive and even. So we should start high, end high. Start high, end high. So let's check this out. Start high. Oh, look back at our factors. Since none of those have, none of these factors have any exponents on them, we know that we are cutting across at each spot of these. No bounces, no waves, no nothing. Just regular cut across. Okay, start high, end high. Start high, cut across, cut across, cut across, cut across, end high. Start high, end high. There we go. So we're just combining what we already knew about sketching with what we now know about factoring. Okay, so you're going to take standard form equations, put them in factored form, and then sketch.